Okay, so the first part of chapter 7 is talking about the rate of change. Either is the function gonna grow, or is it gonna decline or decay? Okay, and that is depending on the formula that's given here. A times b raised to the x, that is an exponential function. Now, the b number that's being raised to the power, if it's bigger than 1, then it's going to be a growth function. If that b number being raised to that power is less than 1, then it's a decay function. So here is another alternative to writing this exponential function where we have a rate of change, okay? Now, this, because it's 1 plus r, that would make b greater than 1. So this would be a growth. 1 minus r would be a decay, because then the b number would be less than 1 if you had subtracted it. So we're going to be focusing a lot on those two functions, okay, for now. And we're going to find the percentage of what it changes and the growth factor. Okay, when it's already combined, the 1 plus r or the 1 minus r, when that's already combined, that is the growth or decay factor. Okay, so here, it's already been combined because it's 1.17. So this technically is your b number. So this is your growth factor. 1.17 is the growth factor. Now, to find the percentage of change, we're going to take that b part on the growth factor, the 1 plus r, so that we can find r because that is the percentage rate of change. Okay? And set it equal to that 1.17 because they already added it together. So if we subtract 1 and we solve for r, so r is 0.17, or if you change it to a percent, because they want the percent, you have to move the decimal 2 places to the right. That function grew 17%. So this is the percent rate of change. So you have to know how to find the growth factor, which is the actual addition or subtraction. If it's a growth factor, it's an addition. If it's a decay factor, it would have been subtracted. And that number would be less than 1 if it's a decay. But since this number is bigger than 1, I knew it was a growth. So I would take the growth factor where the r part is, and I would find r. That gives you your percentage rate of change. Okay? Bless you. Okay, so let's look at a couple more, just to make sure that we're all on the same track. Bless you. Okay, so this is simulating a b raised to the x power. That's simulating an exponential function because the exponent has the x in it, okay? That's how you tell. Okay, now it says, use the properties of exponents to rewrite the equation so that the base reveals the growth factor. Okay, properties of exponents. What do you do when you raise a power to a power? So you're going to go 3 to the second power. So you're taking, because we only want an x out here, but I have a 2x. So I'm going to take that 2, and I'm going to raise it to the third, to the numerator, 3, and I'm going to raise it to the denominator, and then I'll get to reveal my growth factor. Now, if you want to put this in a decimal, you're more than welcome to do that. As a matter of fact, I think we should because we're trying to reveal a percentage eventually. Okay, so let's figure out what 9 divided by 25 is and put it as a decimal. This is 0.36. Okay, so is this a growth or is this a decay? 0.36. Is that bigger than 1 or is that less than 1? Less than 1. So this is considered a decay factor. Now we're trying to figure out what is the percent that it actually decayed. So we take the 1 minus r, because that's the decay part of the exponential function. We set it equal to 0.36 and we solve for r. Divide, we got r equals 0.64, which is what percent? Move it 2 to the right. 64% it decayed. Yes. How's it what? It's because it's declining, okay? So it's going down. So exponential functions can increase, like a population increase, or it can decline because maybe you have some deaths or something like that. So declining means it decays, increasing means it is a growth, okay? It's all based on what this B number represents. Okay, let's look at a couple more. Okay, so 500 represents the A number, 4/5 is the B, but we have to get it only raised to the x power, okay? Not the 3x power. So you have to watch that, especially if you're doing problems and you're trying to figure out what that growth factor is or decay factor, or the percent at which it declines or grows, okay? So we're going to have to attach the third power to the 4 and to the 125. Okay, so this is 64 over 125. Now, let's see what decimal that is. So that's 0.512. Okay, so this is what your growth factor, your decay factor is. That's called the decay factor because it's less than 1. Now we want to rewrite this to figure out what is the percent that it did decay. So we use the 1 minus r to find out the percent that it did decay. So subtract 1. Okay, so if we change it to a percent, we move the decimal 2 places to the right. So 48.8% is the decay. Okay, last one. We're going to get a word problem in here to maybe make it a little more sense. Okay, India's population at the end of year 2019 was 1.37 billion. The country's growth in population can be modeled by the function g of x equals 1.37 times 1.003 raised to the 4x, where x is the number since 2019. So we have to get the x by itself. So you're going to notice on a lot of these problems, it's not going to be raised to just plain old x. You have to use the properties of exponents to reveal that. So I'm going to do 1.003 raised to the 4th power and see what that gets me. Okay, so that's going to be 1.012. So the growth factor is 1.012. Now we want to know what the percent of that is. How much did it grow? What percent did it grow? So we take the growth factor, which is the 1 plus r, set it equal to 1.012 and solve for r. And then move the decimal so we can get a percent. Move it 2, so 1.2% is what it grew.